the highest derivative in this differential equation? Which one is the highest derivative? This one. So this is the highest derivative and it is a second order. Okay, this is not the highest derivative. This is the power. This is degree or power. Any question, please?
না বলছিলাম যে ডিওয়াই কিউটা নাকি মানে হাইয়েস্ট ডেরিভেটিভ
Highest derivative এটা second derivative এটা first derivative. Okay, and this one is the power, not degree. Degree of the differential equation is 3 and the order is highest order is this order, second order term. So this is a second order differential equation. Okay, তো আমরা সাধারণত যখন লিখি ইকুয়েশন তখন y the dependent variable, their first derivative, second derivative এগুলোকে আমরা লেফট হ্যান্ড সাইডে লিখি আর রাইট হ্যান্ড সাইড গুলো রাইট হ্যান্ড সাইডে থাকবে শুধু ইন্ডিপেন্ডেন্ট ভেরিয়েবল কনস্ট্যান্ট অর যদি জিরো থাকে শুধু জিরো থাকবে। ওকে, এইভাবে লেখা হয়। তো এই টার্মটা যদি জিরো হয়ে যায় তখন আমরা বলি হোমোজিনিয়াস। অ্যাজ ফর এক্সাম্পল this one is a homogeneous equation but this one is not homogeneous or non-homogeneous. এখানে একটা ফাংশন অফ x আছে, এখানে রাইট হ্যান্ড সাইডে 0 যেখানে আমাদের x থাকার কথা, x থাকলে থাকবে এখানে, না হলে এটা হোমোজেনিয়াস। সো দিস ইজ অলসো এ সেকেন্ড অর্ডার ডিফারেনশিয়াল ইকুয়েশন। আমরা আরেকটা ক্লাসিফিকেশন করি, ইট ইজ লিনিয়ার অর নন লিনিয়ার লাইক দিস। তো একটা ইকুয়েশনকে যদি আমরা এই ফর্মে লিখি যে y ইনটু কোফিশিয়েন্ট গুলো যদি শুধু ফাংশন অফ x অথবা কনস্ট্যান্ট হয়, ফার্স্ট ডেরিভেটিভ with its coefficient, okay, coefficient গুলো only function of x and so on, তখন রাইট হ্যান্ড সাইড gx। তো এই কোফিশিয়েন্ট গুলো যদি only function of at most function of x হয় আর এই যে y dy by dx এগুলোর পাওয়ার যদি 1 1 1 হয় তখন আমরা এটাকে লিনিয়ার বলব। as for example this one is a linear differential equation. This is linear first order and non-homogeneous. What about this one, second one? Is this linear?
Yes, sir.
It is also linear. হ্যাঁ, এখানকার এই ফার্স্ট এটা জিরোথ অর্ডার, ফার্স্ট অর্ডার, সেকেন্ড অর্ডার টার্ম আছে। ওকে, বাট y এর উপরে কোনো পাওয়ার নাই, dy dx এর উপরে কোনো পাওয়ার নাই, এটার উপরে কোনো পাওয়ার নাই। সো দিস ইজ অলসো লিনিয়ার। যেহেতু রাইট হ্যান্ড সাইড জিরো, এটা নন হোমোজেনিয়াস। What about this? This is linear or non-linear?
Non-linear, sir.
Why?
পাওয়ার নাই এখানে
পাওয়ার নাই কিন্তু সাইন আছে, y এর উপরে সাইন থাকলে সেটা নন লিনিয়ার। ওকে, নন লিনিয়ারিটিটা হচ্ছে আমাদের ইন টার্মস অফ ইন্ডিপেন্ডেন্ট ভেরিয়েবল। যদি ইন্ডিপেন্ডেন্ট ভেরিয়েবলে কোনো নন লিনিয়ার টার্ম হয় যেমন সাইন অফ y, ইট ইজ ডিপেন্ডেন্ট ভেরিয়েবল, y ইজ এ ডিপেন্ডেন্ট ভেরিয়েবল। তো নন লিনিয়ারিটিটা হচ্ছে ইন টার্মস অফ ডিপেন্ডেন্ট ভেরিয়েবল। তো y এর উপরে সাইন আছে এই জন্য এটা নন লিনিয়ার। কিন্তু এখানে e টু দি পাওয়ার x ইজ অলসো এ নন লিনিয়ার ফাংশন, বাট এটা x এর মাধ্যমে আছে in terms of x, so then the differential equation is linear. কিন্তু এখানে যদি আমাদের sin y থাকতো বা e to the power y থাকতো তাহলে এটা নন লিনিয়ার হয়ে যেত। e to the power y থাকলে সেটা নন লিনিয়ার। ওকে, what about this? Linear or non linear?
Non-linear, sir.
Why?
কারণ স্যার কিউবের সাথে স্যার পাওয়ার আছে প্লাস মাল্টিপ্লাই
এখানে পাওয়ার আছে 3।
জি স্যার।
ওকে, dy dx এর পাওয়ার 3, this is why it is non linear. ওকে, এখন আমরা এখানে যেটা দেখব যে এই যে ডিফারেনশিয়াল ইকুয়েশন গুলো আছে এটাকে সলভ, এটার সলিউশন কিনা, এটা কিভাবে ভেরিফাই করা যাবে? হাউ টু ভেরিফাই দ্যাট দিস ওয়ান ইজ এ সলিউশন অফ দিস ডিফারেনশিয়াল ইকুয়েশন? এটাকে স্যাটিসফাই করে কিনা, তাই না? অর্থাৎ এই ওয়াইটাকে যদি আমরা ডিফারেন্সিয়েট করি তাহলে এটা আসবে কিনা, চেক করে দেখো তো এটা আসে কিনা। ডু ইয়োর সেলফ ফার্স্ট, চেক ইট whether dy dx equal to এটা হয় এই ফাংশনের জন্য।
Yes, sir. dy by dx করলে লেফট হ্যান্ড
Yes,
সাইড
sir.
আছে।
Okay, so if you want to do it, how to do, you got it? It does satisfy.
Yes, sir.
Yes, sir.
This is why it is a solution. Now you can also show that this solves this differential equation. Okay, if you find the first derivative, second derivative, and put both sides, it will be 0. Put on the left hand side the y prime, y double prime, it will be 0. Okay, so this is also a solution of this one. So this is not a function, okay, but this is an implicit function. Implicitly there are two function here. Okay, so whether this is a solution or not of this differential equation. So how to differentiate this equation to get dy by dx? Implicit, you can differentiate implicitly. Okay, implicit differentiation. With respect to x, it will be twice x plus twice y. If we differentiate y square, it will be twice y dy by dx, and that is equal to 0. Right hand side constant, so it will be 0. So from this one you can get dy over dx equal to minus x by y. Is it okay?
Yes, sir.
So therefore আমরা এটাকে implicit differentiate করে এটা পাচ্ছি, so this is a solution of this differential equation. Okay, so what is the solution interval? Where does this function lies? Okay, if you sketch the graph you will find a circle. Okay, this one is a circle like this one, from -5 to 5 it occurs. It is a function of, okay, like this. So it is supposed to be from -5 to 5, The domain means that values of x are lies from -5 to 5. But if you take the values 5 and -5, then if you take these values 5 and -5, then what will happen? If you put x equal to 5 or -5, this will be 25, 25, 25, 0, so y will be 0. Or if you take -5, then also y will be 0. But if y is 0, then anything divided by 0, this is undefined. Therefore, we cannot take -5 and 5. It will be after -5 and before 5. Okay? This is why the solution interval is an open interval. So here I have some exercises from your book. You have to take all this from 1 to 6. I don't have all. You have to check the book, and 11 to 13. 1 to 6, 11, 13. These are some checking. Verify whether this one is a solution of this one or this one is a solution of this differential equation. Okay, like before. And about this, whether what is the order of this differential equation, what are the degree of the differential equation, is this linear or non-linear, homogeneous or non-homogeneous, that you have to say. This is the second order, and linear, the first one. This one is the third order and also non-linear. Is it okay? Similarly,
Yes.
you try others. Good. Now we are talking about what is the initial value problem. What is that? So if y equal to cx, if we differentiate this dy by dx, it will be again c e to the power x. Okay, what will be dy dx? C e to the power x, that is again y. Therefore, this is a solution of this differential equation. Y equal to cx is a one parameter family of solutions of the differential equation y prime equal to y. Which is the parameter? C. C is just one parameter. Okay, একটা constant এখানে আছে. So C can be anything from -infinity to +infinity. So how will be the solutions? It depends on C. If C equal to 1, then that will be the graph. If C equal to 2, this will be the graph. If C equal to 3, this is the solution. If C equal to half, then this is the solution. If C equal to 0, then this line is the solution. If C equal to 1, this is the solution. If C equal to 2, that will be solution. If C equal to 3, that will be the solution. So this is there is a family of lines, family of curves. So we call it one parameter family of solution. Okay. So different for different values of C, we have we can choose C arbitrarily. So there are infinitely many solutions. So such solutions are called general solution. General solution. So y equal to cx is called the general solution of this differential equation. Okay. Now, if in this equation we put one condition that y0 equal to 3, we we put another condition, which is this is a equation, this is a condition. Often we call it initial condition because at x equal to 0, y equal to 3. Okay, then how will solution will appear? Here if we put x equal to 0, then y equal to 3, then what will happen? You will get the value of c. X equal to 0 means e to the power 0 equal to 1. 1 into c equal to c. Then y equal to 3. Then it means c equal to 3. Then your solution is y equal to 3 to the power x. What is 3 to the power x? This one. Let us say this is half 1, 2, 3. So this curve will be the solution. Only one curve. So this is a particular solution, not a general one. It is equal to say 3 e to the power x. This one is the solution. If you change the differential initial condition, say for this you choose a condition at x equal to 1, y equal to -2. And if we put this into the solution here, you will get c equal to -2 e to the power -6. Then this will be your solution, which is different than this one. We have the same differential equation, but the condition is different and your solution will be different. Okay, therefore our solution depends on initial values. Okay, even the differential equation same, and such problems are called initial value problems. You will have differential equation with initial different initial value, you get the solutions. So these are called initial value problems. So like this one, we have the we have the similar types of graphs, but this graph is passing through the point when x equal to 0, y equal to 3. The initial value lies on the curve. So this is the solution of the first initial value problem, this one. Okay, and for the second initial value problem, this is the solution. We have -2 e to the power x -1. So that is this curve. Okay, when x equal to 0, y equal to -2. Okay, so that is for different initial value, you have different solution. Later on, we will learn how to find solution in the next chapter, chapter 2. Chapter this is in chapter 2 we learn it in 2.2. This is chapter 1. You can find that this is the general solution of this equation. You can verify it by substituting here y and here dy by dx, or we also can find it by some method which is discussed in 2.2. Okay, now we will see that if we put okay this initial condition y at x equal to 0, y0 equal to -1, okay, then you will get the value of c equal to -1. Can you check it? Please check it. If we use this initial condition into this solution, then c will be equal to you got it here. If we put x equal to 0, y equal to -1. So 1 by c equal to -1. So c equal to -1. Then this becomes 1 over x square -1. Okay.
Yes, sir.
Okay. Then the graph of this function is threefold, like this one. It is separated by 3 different, because from this you cannot get the solution at x equal to +-1. It is not defined at x equal to plus. So this we have to exclude from the domain. Domain include all the real numbers except plus minus 1. And where you have undefined, this will be vertical asymptotes. At this point, it is undefined, and at this point you will have vertical asymptotes. Okay. In between, the graph will be like this, and after 1 and minus 1, the graphs are looking like this. So which graph is the solution graph? What is the initial condition? Y0 equal to minus 1. That is 0 and minus 1 lies. Where does it? When x equal to 0, y equal to minus 1. So this initial point, this lies on this curve. So this solution curve is then the solution. Okay. Mathematically, when you solve, you get this function is a solution. But which means it is when you put the initial value, then initial value lies only on this curve. So this is the solution. Solution lies from minus 1 to plus 1. So these two curves are not the solution. Okay. Therefore, the solution interval is from minus 1 to plus 1. Okay. So this is something what one should know. So that's it actually. Okay. এগুলো আর দরকার নেই, don't need this. Now we will see some differential equation as mathematical models of some physical problems. Okay. How one can model any practical problem by differential equation. This is called mathematical modeling. Okay. This is also called mathematical modeling. And in mathematical modeling, we have some assumptions. We need to take some simplifications, some assumptions, and also we need to identify some variables and parameters. And we use some assumptions. As for example, we give a very simple model of population dynamics. Okay, how populations is changing with respect to time. সময়ের সাথে population change হচ্ছে, human population, any other species, population of any other species, they are changing with respect to time. In that case, the P is the population. We can denote the capital P is the dependent variable, and the independent variable is the time. And this is the total population at time t is a function of time t. Okay, good. We need another. So t is the independent variable and p is the dependent variable. And we also may need some growth rate, which is a. So this is a parameter, growth rate. Now you know that if you have two different cities, say London and Dhaka, okay. So what is dp by dt? Dp means rate of change of population. Say rate of change of the population in 1 year. এক বছরে পপুলেশনের চেঞ্জটা কিরকম হবে? সেটা কি লন্ডনে বেশি চেঞ্জ হয় নাকি ঢাকায় বেশি চেঞ্জ হয়, অথবা বার্লিনে বেশি চেঞ্জ হচ্ছে নাকি ঢাকায় বেশি চেঞ্জ হচ্ছে? Berlin is a big city, larger than Dhaka. In all respect, it is a good city, okay, but the change of the population আমাদের ঢাকায় বেশি। কেন? ঢাকার population বেশি। So this is a practical phenomena that rate of change of the population is proportional to the present population. Okay, this is an assumption, practical assumption, but it is realistic one. So this is our assumption. Now dp by dt equal to a assumption থেকে আমরা এটাকে ইকুয়েশন যখন লিখব mathematically, equal to, we should have take a proportionality constant, dp by dt equal to ap. So this becomes a differential equation where p is population, t is independent variable. Okay, and what is a? আমরা এটা নিয়েছি এখানে, this is actually the integrate, not proportionality constant, but what is really in the problem, this parameter dp by dt into 1 by p. If you write this a, okay, take p on the other side, so it will be 1 by p dp by dt. That is your a, 1 by p dp by dt. So dp by dt was the rate of change of the population, এক বছরের যেটা চেঞ্জ, সেইটাকে যদি আমরা সেই বছরের পপুলেশন দিয়ে ডিভাইড করি, এ হচ্ছে সেই কনস্ট্যান্ট। ওকে, a is that constant which is called the growth rate. A is called the growth rate. So this is a model where a is the growth rate, p is the dependent variable, and dp by dt is the rate of change of the population. This model is called, this is a differential equation model, first order differential equation, and এটার সলিউশনটা কি রকম হবে আমরা আগেই দেখেছি যে this solution will becomes like, okay, so this is the model, আমরা এটাকে সলভ করলে it will be a solution like this one. Can you read this? এটাকে আরেকটু বড় করতে হবে। I don't know, you cannot see maybe. So you know that this is y equal to some c, আগে যেমন দেখেছি আমরা e to the power ax, a the growth rate, এখানে ax like this। তো এখানে y টা হচ্ছে আমাদের p, dp by dt equal to, এখানে যে c টা দেখছি e to the power ax। Okay, I'm sorry, this is not dp by dt, this is only p। আমরা এখানে সলিউশন কার্ভটা লিখছি, সলিউশন, হাউ ডাজ দ্য সলিউশন লুকিং লাইক। pt যখন লিখবো দেন ইট ইজ at, দ্যাট ইজ দ্য সলিউশন। তো এই সলিউশনের এই যে সিটা আমরা যখন t equal to 0 লিখবো, when we put t equal to 0, then p0 is the initial population at time t equal to 0, c e to the power 0. So c into e to the power 0 equal to 2. This implies c equal to p at t equal to 0, যখন থেকে আমরা পপুলেশনটা শুরু করব কাউন্টিং। সে আমরা 2000 তে 2020 এর পপুলেশন আমরা জানি, বা 2025 এর পপুলেশন জানি, দ্যাট উইল বি আওয়ার 25 কে আমরা ধরবো, ওখান থেকে যদি ক্যালকুলেশন শুরু করি সেটা হবে আমাদের p0, অর্থাৎ 2025 এর পপুলেশনকে আমরা p0 বলবো, this one which is given, this should be given। so এটা যদি দেওয়া থাকে p0, then this solution is equal to p0 e to the power a t. The solution of this curve will be like this one। Okay, so this is an exponential curve, exponential equation। যদি a যত বাড়বে এটা তত তাড়াতাড়ি উপরে উঠবে, a খুব ছোট হলে একটু আস্তে আস্তে উপরে উঠবে, you know। So but if we see the graph is exponential, the after some time the solution will increase abruptly, মানে very quickly। Okay, তো এই যে এইভাবে যদি পপুলেশন চেঞ্জ হতে থাকে exponentially, then it is too much change। Okay, then population will increase for a short period of time, it will be too much population, but practically population does not increase in exponential manner। In the beginning it will be like exponential manner, but in course of time you will have to consider some other factors like lack of accommodation, lack of foods and so on, so the negative, there should be some negative factor should be considered। Okay, so therefore this model only, this has some limitation, this can only be applied in microbiology, in the growth of bacteria, okay, or in biology, some fisheries and like that, basically like this। But in case of competition, if we have so many competition with limited sources, then we have to consider some carrying capacity factor that makes a negative effect in the growth process। Okay, say like it was a dp by dt equal to ap. Okay, now when the population are large, they compete each other, so we have to consider a negative term. And p competition means the population p is making competition with p itself, therefore p into p. Okay, this is what the model we have to negative b. So it means that আমরা প্রথমে যেটা if dp by dt is proportional to p and also dp by যখন population dt is proportional to minus p square. ওকে, যখন p স্কয়ার হবে তখন কম্পিটিশন p এর সাথে কম্পিটিশন করলে তখন এটা প্রপোর্শন dp বাই dt গ্রোথটা কমে যাবে, কম্পিটিশনের জন্য নেগেটিভ হবে, প্রপোর্শনাল টু মাইনাস p। এন্ড এই দুটো these two phenomena, if we consider from this one, if you get the same dp by dt equal to a constant say a1 into p, and from here dp by dt equal to say minus b1 p squared. Now if we sum these two, then you will get twice say dp by dt equal to a1 p minus b1 p squared. So what is your dp by dt then? a1 by 2 equal to say ap, and b1 by 2 equal to b p squared. Okay, so this is that model. We have a negative term. এই নেগেটিভ টার্মটা হচ্ছে যে p যখন ভেরি স্মল হবে তখন p স্কয়ার ইজ ভেরি স্মল, ভেরি ভেরি স্মল, সো ইট ইজ নেগলিজেবল। বাট ইফ p ইজ লার্জ, দেন দিস মেক এ নেগেটিভ ইম্প্যাক্ট ইন দ্য গ্রোথ প্রসেস। ওকে, আমাদের যে গ্রোথ রেট সেখানে একটা নেগেটিভ ইফেক্ট পড়বে when p is very large. And this graph, the graph of this one can be shown here. It will be a graph like this. So প্রথমে এক্সপোনেনশিয়ালি হইলেও রাইজ করার কথাই ভাবে, বাট পরে যে নেগেটিভ ফ্যাক্টরটার কারণে গ্রাফটা আসলে এরকম একটা এস শেপ গ্রাফ হবে, এদিকে কনকেভ আপ এন্ড দেন কনকেভ ডাউন। So it will not increase exponentially like this. There will be a limit, okay, that this 25, that will be the maximum population. Say in Bangladesh the carrying capacity is 25 crore, so it will never cross this line. So it is qualitative graph is like this one. প্রথমে এটা এভাবে concave up then concave down. Okay, like this one. So this is one model. Second model is radioactive decay. It is the same. If A is the amount of radioactive substances, then the rate of change of the radioactive substance is proportional to the amount A itself. Okay, so we have the same. A is the proportionality factor, but as A amount is now decreasing, okay, decay হচ্ছে এখানে, so A should be negative. A must be negative here. We have Newton's law of cooling and warming. Okay, this is another model of differential equation. ধরা যাক একটা আমাদের ওভেনে কেক তৈরি করা হলো, করে সেই কেকটা যদি আমরা ওভেন থেকে বের করে রুমে রাখি তখন এটা টেম্পারেচারটা কমতে থাকবে। সেটা কিভাবে কমতে থাকবে টেম্পারেচার? How the temperature start to decrease? Okay, so the rate of change of the temperature is proportional to T minus Tm. Okay, সব সময় এটা কমতেই থাকবে। কিভাবে? And when it is at any time the temperature is T, for any time T, it is a function of T. Okay, this T or this T, and this Tm is the temperature, আমরা বলি room temperature, Tm, room temperature. Room temperature is the temperature of the এয়ার ইন দ্য রুম। তো কেকের চারপাশে এয়ার থাকবে, তো এই এয়ার টেম্পারেচার মাইনাস দ্য কেকের টেম্পারেচার, এটার উপরে it will be the rate of change of the temperature will proportional to this, okay, এটার উপর proportional, এদের ডিফারেন্সের সাথে proportional। সো এখান থেকে আমরা যদি একটা proportionality constant নেই, then dt equal to a into t minus tm, okay. So this is called the cooling. As I have said, the cake will be cooled down during time with respect to time. So this is a cooling. The same model also works for warming. Suppose if you take out some ice cream or something like that from your refrigerator, if you put outside, then what will happen in course of time? The temperature of the ice cream will increase. Okay, and how it will increase? At what rate? Will the same dt by dt is proportional to the difference of the temperature of the ice cream and the room temperature, okay. And so it will be like the same equation only, and on both cases our a will be negative, okay. This constant a is negative for both warming and cooling, it will be always negative. So this is one model we will use at 10 minutes. Okay, so we have another model is spread of disease. We can also see some application of these models in the in chapter 3. But before that, we have to know how to solve these equations, how to solve these models. Okay, spread of disease. We will see also that how we can find a dynamics of a spread of disease. If X is the population number of people who have contracted the disease, okay, in an isolated campus or some town or some village, if the total number of people is fixed, okay, and say, and some are infected and some are not yet exposed, then of course the rate of change of the infected people dx by dt is proportional to x into y. In this case, dx by dt is proportional to x into y. It proportional means always x into y, যদি তাদের মধ্যে interaction হয় x or y, then it will increase. If it is not interaction, then in this x into y means the interaction of two different class of people, two different class of people. So, okay, x and y. X are the people who are already infected, and these are not yet infected. So if they interact, then the number of infected people will increase. So this one also we should have a, if you write in terms of equation, there will be a integrating, sorry, in the proportionality constant, and that is the proportionality constant x into y. But this, can you solve this one? Because here are two unknowns, y and x. This is changing, this is also changing. In that case, to solve this, if we can assume that for a large short period of time, n is almost constant, okay, it does not change. Suppose if we have uh, influenza, flu, okay, flu virus, influenza or something like this uh, exist only for few, only 1 month or 2 months like this, okay, or like this. So in this period in a campus, the total number of students may be constant, okay, so it is n equal to x plus y. Then we can replace this y by n minus x, then this equation will be in terms of x, okay, n minus x. So that is again like the model which we have seen, which is called the logistic population model. We have just seen that logistic population model equal to dp by dt equal to ap minus bp p square. It was like that. P is the this unknown population. Here also, when you write this, one dx by dt, this is dx, okay, equal to a x, and y was n minus x. So n is a constant, a is a constant. This gives you a constant like, say, c x minus a x square, which is like d x square, like this. So similar, it was ap minus bp square, here cx minus dx square. So this is also like a logistic population model, and the graph of this model also like before. Here the maximum population is n, and it will, if it in the beginning one person will be infected, then it will increase like this, and then it will go like this. Here somewhere you have an inflection point, okay. It is from concave up to concave down. Here is the inflection point. Inflection point means এই রিজিয়নের মধ্যে ইনফেকশন রেটটা বাড়তে থাকবে, ইনফেকশন রেট বাড়তে থাকবে, আর এখানে ইনফেকশন রেট আস্তে আস্তে কমতে থেকে একটা এরকম সিচুয়েশনে যাবে। ওকে, দিস ইজ হোয়াট ইজ কল্ড দ্য logistic population model for infection spread of disease. I think we have all these things. We have some more first order model. Like mixture also, we have the first order model in case of this, okay. And series circuit, in case of series circuit, a second order series circuit model, we will also learn this one. We will also show some application of this model. LRC, L for inductant, resistor and capacitor, okay. Inductance, resistance and capacitance, and all these three together component gives you such LRC series circuit. And the equation of this model, the model equation of this circuit is like this one. It is second order linear differential equation, and right hand side you have electromotive force, impressed voltage, okay, et. It is, when it is non-zero, means that this is non-homogeneous. We will also see this, how to solve this first in chapter 4, and the 5 we will solve some exercises of this kind, okay. So, and we have also some harmonic motion problem, simple harmonic motion. So if you have a string, simple harmonic motion, okay, spring, you have a spring without any mass hanging on it, then it is the length of this spring is like that. If you hang a mass, it will increase a little bit. This is called the stress length, and it lies in an equilibrium position like this one. And if you push it down or up from the equilibrium position at any distance x, after that you release it, it will go ups and down, it will move ups and down, okay. And then if we have a question that at what position is the mass now, okay, at what time the position is where, if we want to know this, we have to solve this x, the position, as a function of t. For this you get this such a simple harmonic motion. This is called the for the simple harmonic motion, this is the equation, which is a second order differential equation, okay. Second order differential equation, we will learn this one also, okay. We have also some further things that if you, we will see these types of differential equations, of course, in the next chapters, okay. And এখান থেকে কোনো এক্সারসাইজ করতে হবে না, you don't have to do these exercises, okay. এখানে আমরা এই মডেলগুলো চ্যাপ্টার 3 তে গিয়ে আমরা অ্যাপ্লিকেশন আছে সেখানে আমরা দেখব। Next one will be our chapter 2. In chapter 2 we'll see how to solve the differential equation. That will be easy for you. So first in chapter 2 you will learn that how to solve first order differential equation. Okay, so if we have differential equation like this, dy dx equal to fxy, and this one can be written as a product of two different functions. One is function of x, another one is function of y. Then we can separate the equation and put the function of x with dy and put function of y with dy and the function of x with dx. Okay, and then we can integrate and to get your solution like this one here. The right hand side is fxy is this is the function of x, gx, this is function of y, and this can be put like this: dy by y equal to x squared dx. Then if we integrate, you will get ln y equal to x square x cube by c ln c. If you take this on that side, you will get such a solution. Okay, this is called the method of separation of variables. Okay, but this one cannot be solved by this method. It cannot separate these two and just putting y with dy and x with dx, not possible. So for this we have to learn some other methods, but if it is separable, then we can solve this by this method which we discuss uh, in this part. Okay, say example 1 in 2.2. Can you check it what we have done here? Do every steps and try to check whether you understood or not. Okay, so first you write this, from this one can be written, and then you, using the concept of cross multiplication, you can just write this in this form. Now if you take integration on both sides, you have to take here ln of the modulus of y. Okay, ln on the modulus of y. Why? Only ln y is not good enough, because if y is negative, then it is not defined, therefore you use this term. Here also ln of this cannot be negative, it means this should be always positive. But if you do not use also this modulus sign, it is at the end you will get the answer. But you can use this because integration of anything, say y, 1 by y is always ln of y, we write it like this way. Okay? And now if you have ln a plus ln b equal to ln a into b, which will be c into x1 plus x. So ln y equal to ln c into 1 plus x. So y equal to c into 1 plus x, like that. Okay? Ultimately, you get the solution in this form. If you say y, first we take c1, because somewhere if we have the modulus sign, then we write in this form, then y by modulus of c1 equal to this, that is modulus of y equal to c1 into this. And if we remove the modulus, then there will be plus minus, and this plus minus we c1 we write at the end c. This is why we have taken here c1. Okay. So this will be the solution, it will be like this one. So we have some exercises, like you have to do only these exercises. There are something is solved here. Say this one is very simple. To do this, just you have to integrate this function. Okay. If dy by dx equal to this, what is your y? Just we have to integrate this. But how is the process? So dy equal to this, then they take integration on both sides. Then d and this integration, they cancel each other. We have y equal to minus cosine 5x by 5 plus c. This is what you have learned already, the integration, how to do the integration. This is also the same. If we how to solve this, we separate this x and y and then solve this. Okay, this one with initial value. Okay, you have to solve this differential equation with this initial condition. In that case, you have no c. The general solution, it will be not general solution, it will be a particular solution. Okay, like here you had a c. Okay, but in the general solution you have a c, but this time you will have no general solution. Okay, so after that, after this, when we have c, we will have to find the value of c by using the particular value. Okay, if you use the particular value over there, then you will find in this equation, then you will find that tan inverse 1 equal to 4 pi by 4. That is x equal to 1 when t equal to pi by 4. So put t equal to pi by 4, x equal to 1. So tan inverse 1 equal to pi by 4. Pi by 4 equal to pi plus c. So c equal to this. So what is the solution? Put the value of c. This is that particular solution. Okay. This is the last one. You can check whether it works for you. So you got it, how from this one becomes this equation. Can you check? So is it okay?
Yes.
Okay, so at the end you have to find the value of C and put it there. Okay, so these are the things. You do the rest of the exercises yourself and we will continue this. Okay, chapter 2 of differential equation. Thank you very much for your attention. If someone has missed the attendance,
So I have missed